So, welcome everybody to the first edition of the online CV and AI workshop slash hackathon. My name is Jose, and I will be your hackathon leader for today. Today with me we have my assistants Rain, Wu, Ric Tu, and Jacob Chen. Would you guys like to give a brief introduction about yourselves?
Okay. Hi, my name is Rick, and I will be the assistant of this hackathon, and I'm also a master student of Nordling Lab.
Hello, I'm Jacob Chen, and I also is the assistant of this hackathon, and also is the master student in the Nordling MCKU.
Hello everyone, my name is Ren Wu. I'm the chat master of the hackathon session. Please feel free to write your question and comment in YouTube and Twitch chat. I will gather them and report to the hackers. Thank you.
Okay, thank you guys. So once again, I would like to welcome everybody. As I mentioned before, my name is Jose. I am a PhD student here at the Nordling Lab. We are broadcasting this workshop from the lab in NCKU in Tainan, Taiwan. Please write in the chat, where are you watching this from? We would like to see what kind of people, from where are the people watching? So today, what we have for you is just a brief introduction about the OpenCV and Depth AI. So for those of you who have this product, we will try to use this product to do computer vision and spatial AI tasks. So before we start, there's a couple of things, useful things that I would like to mention. So first of all, you can find the link for this presentation and also a link for a repository in which you can upload code and submit a push request, and then we can download your code in the case that you would like to run some code. Like let's say you don't have the camera and you would like to run a code, right, that you have written, and then we can do that for you as well. Another thing that I would like to mention is that this is supposed to be some type of collaborative learning. So while I am the leader hacker, this is meant for us to learn together, right, and do stuff together. So if at any point you have any comments, questions, or concerns, please feel free to write it down on the chat, and I guess Rain, the chat master, he will be reading them. If there are several people who have the same question. So having said that, I guess we can go into what we have outlined for you today. So as I mentioned before, this is a brief introduction of the OpenCV. Might as well name this presentation Introduction to OpenCV and Depth AI. But for today, the first thing that we will discuss is what kind of components actually come when you buy the OpenCV camera set. Then we will go into Depth AI. So Depth AI is like the platform that you would use to write code that you can use to do applications with this camera. Then we will get into the more practical stuff of the workshop, which is we will teach you how to install the camera, how to verify that you have installed the camera correctly, how to use the different cameras in this product. Then we will also go into the case, like let's say that you want to use two cameras simultaneously, right? What if you want to record stuff with maybe two cameras at the same time? How would you do that, right? And lastly, we will just discuss about how do you encode video into a compressed format, and we will try to push the limits of the camera in terms of resolution and frames per second to see what is actually the highest resolution of data that you can get. So please stay tuned for that. So let's get into it. So the first thing is the OpenCV. So when you buy this product, which is a very nice product, I must say, you will get several things with it. The first thing that you will get is this 12 megapixels camera that can collect data at a maximum 60 frames per second. You will get, it also has these two cameras on the side, on the left and on the right. These are monochromatic cameras, so they can only record data in black and white. And they are 1280 times 800 pixels of resolution, and they can record data at a maximum of 120 frames per second. And inside the camera, we have the AI processor. This AI processor is the Intel Myriad X Visual Processing Unit, or VPU for short, which is used for accelerating computation for computer vision and AI. It can deliver roughly 1 trillion operations per second to run inference on a deep neural network, and it has over 20 hardware accelerators to perform basic computer vision tasks, like, for example, stereo vision or optical flow. So it is actually a very useful thing if you want to use it for online AI. So let's say that, for example, you want to run a model, but maybe your laptop it doesn't have a fast GPU or a fast processor. Then you could run the model in the OpenCV, right? Or you could do it, for example, in a Raspberry Pi, which is not such a potent computer for calculating stuff. Then you could use it. You could use the OpenCV to do all of that calculation inside the camera, and then just obtain the values from it. So now we're going to Depth AI. So Depth AI is, well, let's take a look. So Depth AI is a platform that combines hardware, software, and firmware to provide an end-to-end solution to embedded spatial AI and computer vision. So now here we have two key terms. The first key term is computer vision. Computer vision is, I believe, is a term that probably most of us have heard. I suppose. I guess if you're joining this workshop, is because you have some level of interest in computer vision. So basically, this is the field of science that aims to teach computers to see the world as we see it, right? To have because we as human, there are certain tasks that we can do because we have our visual perception system that are very easy for us. Like, for example, detecting a faulty part in a production line, or determining if a person is a male or a female, right? Or let's say that you're watching a screen and you want to detect where is a basketball in the screen, right? All of this stuff is very easy for us to do. And what the idea of computer vision is, we want to teach the machines to do this kind of stuff for us, right? To automate this task for us. And spatial AI, as defined by Depth AI, is the superset of 2D convolutional neural networks being extended to 3D by giving them spatial information. So what is that? So here, for example, as we can see here in figure 2, let's say that we have a neural network that has been trained on images, like 2D images, and these images, so they contain a red ball, right, in the frame, and the objective of the neural network is to locate that red ball, right? It's an object detection network. So the output of that neural network will be a vector that contains the information of where is the red ball on the screen and what area of the screen corresponds to the red ball. So it will give you, for example, like a vector containing the bounding box center x and y coordinates, and it will also contain the width and the length of that specific bounding box, right? So now, if we, for example, added spectral information, so like let's say we calculate the stereo depth using this camera, then we can combine these two, the prediction of the object detection network and the depth information, to obtain a point cloud in the 3D space that could tell you, okay, this ball, in addition of being, for example, 4.6 meters in the x direction and 7.41 meters in the y direction, is also 8.34 meters deep, right? relative to the camera, of course. So here I like so Brandon, I believe his presentation was on Tuesday. Rain, if you could please provide the links for the other presentations in the chat, that would be very great. Brandon, in his presentation, defined spatial AI as a capability to get neural inference result in a physical space, which is in accordance to what we were discussing before. And he mentioned that it was a tight fusion of AI, computer vision, and depth. So you could use, for example, AI for object detection, as I mentioned before. You could use a CV for maybe tracking the object, and you will use the depth, right, to obtain that 3D, the spatial context in order to give to extend those 2D results into 3D. So in practice, what it would look like is like this here. So here we have a picture of a strawberry, right? And in here you can see like the relative X, Y, and Z coordinates of this strawberry, right? And the most interesting part is that you could do that real time, because you have everything that you need to do this inside the camera. So another thing that is very interesting and is worth noting is that here we are discussing about object detection, which is like the box. You could also extend this to, for example, pose estimation. So in pose estimation, what you will get would be like the location of certain key points, right? And you will kind of like join those key points in an image. So you can also extend this into 3D. And or for example, semantic labels. So the difference between semantic segmentation and object detection is that in semantic segmentation, you want to classify each pixel of the image as being any of the classes that you have trained it on. All of these results could be extrapolated into 3D by adding depth information. So it's actually very, very, very interesting concept. So now I have my camera, right? And I know what kind of platform I need to use to write code for it, which is Depth AI. So now, what would the structure of the code be, right? Typically, we have identified that it basically follows this flow. So the first thing that you need to do, at the top of your script, you need to import Depth AI and all the required packages. So for example, you would require OpenCV, you would require NumPy, you would require SciPy, whatever, right? Then you need to define a pipeline. So a pipeline is basically just you define components that that are inside the camera, and then you connect them through links, and so that the camera can automate that by itself. And then you need to also define nodes or components to be able to send the information from the camera to the computer, or from the computer to the camera. And we will discuss a little bit about that later in much more detail. Then the third step is, once you have defined your pipeline, then you need to start your pipeline, right? So basically, the starting pipeline is basically assigning which device will use which pipeline. Then once you have started your pipeline, then your device will start collecting data, right, and outputting values, either values that corresponds to images from the cameras, or from the stereo vision, or from the inference result of a neural network. So that will come in a form of a queue. And then once you're getting those values, right, then you can start to post-process them to obtain then whatever result you want, right? Whatever it could be, maybe plotting a bounding box, or classify something, or whatever. So this is actually very important, and I would like you to please pay attention to this and kind of like remind yourself, because when we're doing the code, you actually see this pattern come out many times in the code. So we need to import a pipeline. Import our packages, define our pipeline, start our pipeline, get data from queue, and the post-processing. So here I just have an example diagram to kind of visualize what do I mean by what I explained before. So here, for example, I have my device side. So my device basically corresponds to the camera, right? In here, I could create objects that will do stuff for me. So for example, like if I have this is a code for face detection neural network, right? The camera will take pictures, and then a model inside the camera will run inference on those pictures to predict the area that corresponds to a face in an image. So the camera will take the picture, right? And then the camera would pass that information to the AI model. In this case, this AI model is a face detection neural network. And then the model will output a result. Now, how does the computer and the camera communicate with each other? Well, they communicate through this middleware that is called X-Link, as we can see here at the edge of the device side. So the X-Link, you have two types of X-Link. One is X-Link in, that allows you to send information from your computer to the device, so to the OGD. So let's say that maybe, for example, you have a video that you already filmed, right? And you just want to run inference on that video. So you would send that video to the camera, and then the camera would just, kind of simulate that it's filming it, and then it would just pass it to the AI model. And then how does the device send information to your host? It will do it through X-Link out, right? Like that will be the opposite of X-Link in. So in this case, we want to plot the frame that we are collecting from the video, and also we want to plot the result of the neural network. So here, that's why we require two outputs from the camera, one being the frame that is collected from the camera, and that's why here we have this X-Link out in the middle. And in addition, we require the output of the neural network, and that's why we have this third one on the bottom. So here we just show the frame and combine these two results, right, of the neural network with the neural network, and then we'll be able to obtain what we want. So kind of like piggybacking on the points that I was making before, we could use the camera on 3 different modes. So the first mode, as we would like to call it, is data collection mode. So you could use the camera to simply just take video, right? Record video and just save that video for training or for any application that would you like later. So you can collect information from the RGB camera, from the 2 mono cameras. Then the next mode will be production mode. So in production mode, what you will do is that the camera will collect the data. It will collect the pictures, and it will run them through a neural network. And the only thing that you output is just the inference result of that neural network. And then you do post-processing of that result, right? That's what you will do in production mode. And then the third mode, which is the mode that we will be using for most of the workshops from here on out, is development mode. So development mode basically means that, okay, I'm creating this neural network, and this network is producing an output on my images that I'm collecting. But I also want to check if the results of my network make sense, right? So for that, I will need also the input data of the network as well. So I will get the input and the result, the input and the output of the neural network, to compare them together, right? To see if I want to make any changes to my hyperparameters or something like that. So as I mentioned before, we will be working with development mode for most of the codes in the workshop. So installation. So here is the part where we're going to get more practical. So I hope that everybody at home has their camera with you. So let me show you. So the camera comes like this. And if you turn it this side, you will see that it has two different ports. One is a USB-C port, and then one is the power port. You want to connect with a USB-C to USB cable. You want to connect your USB-C, and then you want to connect your USB side to your computer. Okay, please make sure that you have done this, otherwise it will be very hard to verify the installation afterwards. Please comment on the chat if you have the OGD. How many of you have the OGD with you at home? Yeah, please write in the chat. We would like to, you know, kind of just know this kind of information. Okay. So now, can you see can you see that I'm using this file explorer or no? Yeah, nice. So let me, okay. So let's start. So I'm using Windows, so I would start PowerShell. For those of you who are using Linux or other systems, I guess we are just deeply sorry. And we would, I guess, one of the things that we would try to focus on for the next one would be to have an installation for these different operating systems. But for now, if you have Windows, please try to follow me. So now, the first thing that we want to do is to install this package that is called virtual env. So we can do that by just simply pip install virtual env. So I actually have this package already, so it says that it's already satisfied for me. But for you, it will, you know, show this progress bar, and then unless you have something very strange with your computer, it should be able to download fairly quickly. Then the next thing is we want to create a virtual environment, right? Now that we have this package to create virtual environments, we want to create a virtual environment, and we want to name it OGD, or it could be any name you like, but for this tutorial, we'll just call it OGD. And then we wait to see if it can create it. Nice. Apparently there is no problem. So now we want to go inside our virtual environment. So we just go, let me just move it here. OGD scripts activate. Aha. And it did it correctly. How do I know that it did it correctly and I'm actually in my environment? Well, it's because there will be this thing on the front of my name, I would say. And this should be the name of your virtual environment that you set it. So for example, let's say that in this line you set a different name, then that name should appear here, right? Okay, so since we don't know exactly what kind of level are the people from that are attending this live stream, we don't know if you're beginners or experts at computers and OGD. Yeah, please also write from 1 to 5. How would you rate yourself using the OGD? And so a virtual environment, just let me quickly explain, is like it is like a it's an environment. So it's like a mini computer that lives inside your computer, but it's virtual. So why do you want to use this in this case? Because let's say that you have your Python, right, in your computer, and you have installed packages like, or dependencies like TensorFlow, or you have installed Keras, and all of these packages have a certain version, right? But in this case, the virtual environment is useful because let's say that you want to run a different code, right? And this code uses different packages and different versions of these packages. So you don't want to, change back and forth from the version of your packages, right? Because then that can cause your code to crash very easily if the versions are not the adequate ones. So what we're doing is to create this virtual environment in which we'll install. It's like an empty computer, right? So now we will install packages inside of it, so that we can run the code that we have for this workshop. Does anybody have any question about that? If you have any question, please ask in the chat, and Ren will let me know, and maybe me and my assistant hackers, we will be happy to help you. Okay, so now let's get into installing depth.ai. So depth.ai is actually a fairly easy package to install. We can just use pip install to do it. So we're going to pip install depth.ai. We want to use version 2.5. Okay. So I have installed it just recently. So I have this cached version. So it will do it for me very quickly. For you, it might take a little bit longer, but it should be still fairly quick. You see this progress bar filling up until you have it. And then one more thing that we want to do is to install OpenCV, because we will also use OpenCV in our workshop. So you can just do that by doing pip install OpenCV Python. And like before, I have my cached version, so I install it very quickly. But for you, it should be also fairly fast. Okay. So now we want to verify that our installation has been successful. So the easiest way to do it is to just go into a Python environment. You want to run these lines. So you want to import depth.ai as die. You want to print the device to get all the available devices. Print die device get all available devices. Okay, and it did it for me. What is this showing me? So it's showing me the addressing memory where I have this camera object located. So let's say that, so now I have one camera, right, connected. What if I don't have any camera connected? Let's say now I'm going here and I'm disconnecting my camera. I don't have the camera connected to the computer. And if I run this code, I wouldn't get anything because there's no camera connected. What if there's a case where I connect both of my cameras? Oh. Yeah, didn't. I connect both of my cameras, and then now I can see two different outputs right here because I have two cameras. So yeah. So now I guess we can, now with the camera installed, sorry, with the depth.ai installed and with the cameras, I guess we can move into a little bit more fun part of the workshop, I would say. So camera control. So the first thing that we want to demonstrate, or that we want to try together with you guys, is we want to write a script that can collect data from the 3 cameras that we have already discussed previously. So from the monochromatic left, from the middle RGB, and from the mono, and bring it to our host here. And we also want to calculate the depth real time, right? And sorry, not the depth, the disparity. And then we want to send that disparity map also to the computer, and we want to upload these 4 frames as an output. So I suppose, then I should just let me just create this empty script. And wait a second for me. So yeah, so here maybe my assistant Rick would like to give you a brief explanation again of what are we going to do here from the diagram. Well, as I code.
Okay, so in this code, in device side, we will create 4 objects. And the first one is the color camera. And the output of this camera will link to X-link out. And X-link out is for sending the data to our host site, which is our PC. And the data in this case should be our preview, like you see in the right-hand side. So the second one is we will create 2 objects. It's the mono camera, one for left and one for right. And both of that will connect to X-link out also and send out the preview of there. And those 2 cameras, the left mono camera and right mono camera, will also link to another object called stereo depth. And the stereo depth will provide a disparity map. And the disparity is actually the pixel difference of the 2 cameras. So you can see in the right hand side, the preview from the 2 mono camera is slightly different, and the difference is the disparity. So the stereo depth will also link to X-link out and send out our disparity map.
Thank you, Rick. Could you explain to the people as well, why do you like, if we want to get the depth information, why are we calculating the disparity? What is the relationship between disparity and depth?
Yeah, so the disparity is the pixel difference from the 2 camera, right? And so with that information, we can use the focal length of the camera and the baseline, which is the position of the 2 camera, and we calculate to the depth. So the calculate is actually the focal length times baseline divided by the disparity will be the depth in that pixel.
Yes, thank you. Yeah. So the typical way to find the depth information is, as Rick mentioned, is to find the disparity between 2 rectified images. So rectified images means that you are going to calculate the epipolar lines in the images, and you're going to make sure that the epipolar lines are, number 1, they are horizontal, and number 2, that they are at the same y level, so the same height. And then you want you want to start, for example, like you have the image in the left, and you want to find the disparity of a specific pixel over there, right? So that pixel is on the top of an epipolar line. So then you will go to the right image, to the second image that you have, and you will start looking on the epipolar line, right, for where is that pixel. So if I have two images, right, if the difference is large, the disparity is large, that means that the depth is small, is short, because depth and disparity are inversely proportional concepts. So I guess, we will demonstrate a little bit more about that later, but for right now, I would like you to take a look at my screen here, and what am I coding. So here I have imported my depth.ai package as DAI. I have imported my CV2, my OpenCV2, and I have imported NumPy as MP. And now that I have imported my required packages, the next step in the flowchart was to define a pipeline. So that's what I'm doing right now. I am defining a function that is going to return me a pipeline. Okay. And this function, I call it stereo pipeline because I'm gonna eventually calculate the stereo, but it's going to do all of this. So as we see here, the first thing that we do is to define a pipeline as depth.ai pipeline. Then I need to start defining the components that are going to be inside my pipeline. So what is my first component? Well, if I look at this diagram from top to bottom, the first component is the color camera, right? So I'm creating that color camera, and I'm setting a preview size of 640 times 400 pixels. And that component is going to be connected to an Xlink out node, right? This Xlink out node, as you mentioned before, is how it is to send the information to the computer. So that's what I'm doing right now. I'm calling that Xlink out X out, and I need to set the stream name for this. Set stream name, and I'm not very fancy with names, so I'm just gonna call it RGB, and we're going to print created color camera. So I don't know about what coding practices do you have in your labs or in your companies, but I think it's very good practice to, as you're coding, to run your code to see if you have any bugs, because otherwise you end up with some bugs that if your code is long, that you cannot fix, right, eventually. So we do a pipeline, and then we're gonna call this function. We wanna create stereo pipeline. And now I am going to bring my console, and I'm going to run my test script. Oh, because I need to go to the OGD directory. Okay. Oh. Okay. It printed out what I told it to print. So it means that all the code here is no problem. I called the functions correctly. So the next thing to do is to create these two mono objects. So we have the mono left is the pipeline create. So if the color camera is create color camera, to create the mono object is to create mono camera. And then we also have a right one, so we want to use pipeline create mono camera. So now, how does the computer know which one is the left and which one is the right camera, right? I mean, it's not just because I name it like that. So I need to specify, I need to define the board socket of the camera. So you do that by set board socket oh no, camera board socket left. And then likewise, we're gonna have a mono right, set board socket camera board socket right. And the default resolution for these mono objects is 720p. So that's actually a little bit too large if I want to show the four outputs in my screen. So I'm going to change the resolution of that to 400p. So the way that we do that is set resolution time mono camera properties sensor resolution the 400p, and we did it for the left, so we're going to do it for the right. Mono camera properties. Why did it do that? Why did it do that? Sensor resolution the 400p. Okay, so now we have these two cameras, right? And these two cameras are going to send the output. We're going to collect this output from this X-Link out nodes, right? So we're going to create X out left is pipeline, okay, X-Link out, X out, right? Because everything we do for the left, we need to do it for the right. Create X-Link out. And we need to also set the stream names for these cameras, for this node, sorry. So X out left, set stream name, let me call it left, and X out right, set stream name, and let me call this one, surprise, surprise, right. And let me just print something so that I can make sure that everything is working fine until now. So we create a mono camera object and we run this code. Okay, no problem. It created a color camera and it created a mono camera. So now the next thing will be to create this stereo thing. So we want to call it stereo is equal to pipeline. So create stereo depth object. So you can see every time you create an object is create color camera, create mono camera, create stereo depth. Okay. Now we need to define properties of this stereo depth. Stereo set confidence threshold, and then we need to set this to 200. So when you're calculating the disparity, right, the disparity has a cost function, and you know if the cost is very large, then the confidence will go low. This confidence goes between 0 and 255, and there are 0 is being the most strict. So you need to have the cost values that are very low in order for you to have a high confidence, right? Otherwise, yeah, the confidence will be just set to 0. So here we are actually being fairly lenient with this threshold value. And then we also need to create an X out, right? Because we're going to send the disparity of that stereo object to the computer as well. So let me create an X out stereo that is going to be pipeline create X-Link out, and I need to set a stream name for my X-Link out, which is going to be stereo. Okay, and then I'm going to print created stereo object, and I'm going to run the code to make sure that everything is working fine, of course. Okay, perfect. I created the color camera, I created the mono camera objects, and now I created my stereo object. So now it's time to link all of this stuff. So link what with what? Well, the first thing that we need to link is we need to link this preview of the color camera to its respective X-Link out. So we go, I'm just gonna make this comment so that we can know that from here on out it's linking. So we want to get, what do we want to get? Become RGB, we want to get its preview. I want to link that to what? We want to link that to the X out RGB to the input of this. Okay. Then we want to do the same thing for, we want to get the output of the two mono cameras from to the respective X-Link out. So we go mono left, and in this case it's not preview, it's this out. We want to link to the X out left the input, right? We want to link to the input of that. We want to link the mono right, this output, link it to what? To the X out. Okay, now here we have that the output of this left and right camera, yes, they are linking to this X-Link out, but they're also linking to their inputs as well to this stereo object, right? Because the stereo requires the two images for it to calculate the depth. So let's link them. So in addition to link them to the X-Link out, so I'm going to link the out, and we're going to link them to their respective left and right input. So we're going to link it to the stereo left, and we're going to link the mono right out link to the stereo right. And finally, we need to get the output of this stereo object to link to this X-Link out. So we get the stereo, and this stereo has different outputs, but in this case we want to get the disparity, and we want to link that to the X out stereo to its input. Okay, and lastly, I want to just print created pipeline, just to make sure that the linking is fine and everything is working okay. So okay, yeah, I created a color camera, it created a mono camera, and it created a stereo object, and it finally did the linking, right? Okay, so we have imported all the packages that we need. We have defined our pipeline. Now it's time to start our pipeline. So to start our pipeline, we just first define a device. So device is device, and we need to assign a pipeline because the device needs to work with a pipeline. Which pipeline we're going to assign it? The pipeline that we created just now. And to start the pipeline, we're just going to go device start pipeline. It's as simple as doing this, and we're going to print pipeline started. And then I'm going to run the code to see if everything is working fine. Okay. Nice. It just gave me a deprecation warning, but it actually printed the pipeline started. For those of you who have your camera at home, you will notice that now that you have started your pipeline, it will make that little sound like when you install a USB, boom, pururu, and then it will automatically turn off, boom, pururu, because we didn't do anything with that with the camera, right? So now we have defined our packages that we need. So we have imported the packages that we need. We have defined our pipeline. We have a starter pipeline. So now we need to get the values from the queue, right? But first, I need to define which queues are going to the queues and from where they're gonna get stuff. So you define a queue by getting the queues from your device. So you get device, get output queue, So which queue? Then you need to give it. You need to specify the name. So as I have mentioned before, so this queue is for the RGB. So I'm going to get the stuff from the queue that is named RGB, which is the camera, right? And then I'm gonna apply a max size of 4, and I'm gonna make it blocking false. Maybe Rick or Jacob would like to explain what is this max size and blocking parameters and how do they affect the behavior of your queue as I continue writing the other queues.
Okay. So the max size and the blocking in the queue get image, because normally we will not just getting the one information at one time. So if this does not setting, this will be too many memory losing. So there we're using two way to setting this kind of the memory control. And so the first is this max size. So as shown here, we can see our max size is 4. So if we don't set in this max size, the original setting will be 30. But we setting here as 4 is mean the max size will be 4 in our container, and then if more than 4, it will be draw out. And the blocking is here we can see our blocking is 4, and so we have two choices. One is 4, one is 2. And why here is 4 is because the dropout behavior will be start from the previous data, and if your setting is true, the drawout behavior will be start from the new data. Okay.
Rick, would you like to add something to that?
Okay, so the data we get from the XML is basically a queue. You can imagine it's like a line, and you have many objects on the line. So the max size 4 is mean on your line you only have 4 objects. So as Jacob said, if you setting like the max size 100 or 200, it will like the 200 object on your line, it will cost a lot of memory. So for saving memory, if we just need 4, you can just setting 4. And so for the blocking is the behavior change is like the queue is the first in first out the property. So when the blocking is true, when you drop out the object, you will drop off from the first object. And when the blocking is a false, you will drop off from the last object. That's the difference.
Okay, thank you guys. So now I have defined my 4 queues, right? And the way that I get an item, and I have started now my while loop, so to start doing post-processing. So all the post-processing is going to happen here inside the while loop. So the first thing that I'm going to do is like I'm going to get a single item from my queue, right? So the queue contains at maximum 4 items. Okay, so now the problem is that once you get an item from these queues, the item is actually a depth AI image frame. Let me demonstrate that by running this code that I have here. Yes. So let me stop the code. So now you see, I am printing what is inside in RGB, right? And it's printing that it is a depth AI image frame object at this memory location, this memory address. The problem with these depth AI image frames is that they are not so easy to manipulate. Like, for example, if I want to, show it, right, using a CV2 show function, like I just defined, the window name, and I tell it, okay, could you please show me what is inside in RGB, and I need to, don't forget to write your wait key, otherwise your image will not change and it will stay there forever. So if my wait key is the ordinator key Q, I'm just going to break it, So then I'm gonna go test. Okay, it give me an error. Why did it give me the error? Because I cannot do this. I cannot plot this, right? Uh, so how can I actually convert this into something that is more easy to manipulate? Then the way to do that is you apply this function. You call it get CV frame, and now if I change, and if I change this now and I save it and I run it, so first thing that you're going to notice is that it actually can print the RGB data that is collecting from the camera. Hi, everybody. Number two, it is actually printing the matrix here, right? Obviously, you cannot see the matrix because the matrix is very large, but what you can see is will be probably the shape of this matrix. Okay, and let me quickly stop it. So it's outputting that the shape of the RGB frame is 400 times 640 times 3. Why is it 640 times 6? So what is 400 times 640 times 3? Well, because previously on the top, we have defined our preview size for this frame to be 640 times 400. And is 3 because we have 3 color channels, RGB. Okay? So let me do a similar operation for all of the other cues. So let's call it in left. Sorry. Frame left is in left. Get CV frame. Frame right is in right. Get CV frame. And let me call this disparity map is in stereo get CV frame. So now instead of before I plot all of them, I would like to demonstrate what is it that you get when you print the shape of the monochromatic cameras. So let's take for example left. Okay, so let me stop this again very quickly. We are getting a shape of 400 times 640. Why are we getting that shape? Because the resolution that we have set in this camera, if you remember, was 400p. So if you Google what is a 400p resolution, you see that it's a 400 times 640. And now we only have one channel, right? That's because it's a, like I mentioned before, it's a monochromatic camera, so it collects data in black and white. Okay, so then we can just try to show all of this stuff by using the CV2IM show function. Left, right, frame right, and CV2 IM show. Let's call it disp for disparity. Disparity map. Okay, and we're going to run this. Aha. Oh, sorry. There's a little mistake here. There's a little mistake. Stereo name. Oh yeah, because the in stereo is getting from the right, so actually that's wrong. So it should be Q stereo. And let me try to run that again. Aha, now it is working. So what are we seeing here? On the top left, we have the image from the left camera. So I don't know if you can see that I'm holding the camera like this, and I'm gonna cover, well, in this case, my right is your left and your left is my right. So I'm covering one of the side cameras with my finger. Okay, so apparently it's the right. And you can see now that the on the right side is occluded, everything from my finger. If I get my other finger, I will cover the left, and you can see that it's also occluded, and the camera is trying to adjust for the brightness now. But then you can also see that the disparity map cannot be shown because the disparity requires the two images, right, to be of the same object. So now we have kind of like prevented the algorithm to calculate the depth. And here on the right, we have a disparity map. So the disparity map basically tells you the difference between the left and the right images. And now the brighter values are larger disparity, meaning that the object is very close. So the more wider it is, the closer, the brighter it is, the closer it is to the camera. So as I, for example, get far away and start to move my hand to the camera, it will start getting brighter and brighter and brighter until there's this point where it cannot calculate the disparity of my hand. Why? Because I'm getting below the minimum depth. Okay. Now, speaking about the minimum depth, let me print what is the minimum value in disparity map and what is the maximum value. Okay. Okay. Nice. So as we can see here, what kind of values are we getting for the disparity? We're getting that the minimum value is 0, the maximum value is 95. Why are we getting this 95? It is because, as I mentioned before, disparity is calculated when you have, for example, an image on the left, and you want to find a point the disparity of a point in the image on the left. So you need to go to the image in the right and start looking in the epipolar line, right, for that point. But you cannot do that for the whole line because that would be very computationally expensive. So what the algorithm does is that it gives it a range in which it can look. So that range defined here is 96. So Python starts with 0, so it's actually 95, right? And that's why the maximum value that you can get for disparity right now is 95. There are two problems with this. The first problem that we need to address is that since we're doing CV2 IM show, OpenCV assumes that this is a uint8 image. So it assumes that the maximum value that you could displace is 255. So that's why we're getting a lot of grayish shades. So let's try to correct that by applying normalization function to our disparity map. So let me go here and define a normalization function. Let me call this function min max norm. What this function going to do? It's going to calculate the minimum value of my x, try to get the maximum value of my x, and it's going to return the normalized value for x, because that's going to be x minus x min divided by x max minus x min. So there are some cases when the camera is starting that it gets 0, so let me just add like a very low number so that it doesn't give me, so that I don't try to divide by 0. And yeah, so now my disparity map is going to be a disparity map, but passed through this function. So for those of you who are familiar with this function, you will know that this function returns the values between 0 and 1. So 0 being the lowest value that you used to have, and 1 being the highest value that you used to have. So that it will kind of like stretch them, right? So now you want to multiply times 255. So then instead of being from 0 to 1, is 0 from 255. And we want to make them a uint 8, right? So that we can plot it on OpenCV, using OpenCV. And we're going to run this. Okay, so now I'm getting, what much brighter shades of white, as you can see. Great. So now, what happens in the case where you would need to deal with smaller minimum lengths, right? Because right now, let me move this here. You could, you could extend the search, your disparity search, by modifying certain properties in your stereo object. So let's go back to the pipeline. And in the stereo object, let me set extend as true. Okay. And remember, we are showing here the maximum disparity and minimum disparity before the normalization. So before it used to be from 0 to 95. And now if I run it again, yeah, you can see, first of all, there's a change in the map. And if we take a look at our terminal, we can see that now the values, they are ranging from 0 to 190. And what effect does this have? Well, that means that instead of allowing our algorithm to search 96 pixels in the epipolar line, we're allowing it to search 190, right? So what does that mean? As I mentioned before, right, disparity and depth are inversely proportional concepts. So if two images are very close, the disparity is going to be very large. So by allowing it to have almost double the disparity search, we're allowing it to have half the minimum length. So you can see, actually, I don't know if you can notice, but if I run this code again, I can actually get my hand much more closer to the camera before it starts to go wrong. Here. Can you guys see it? Let me try again. Try to get remember where my hand is. Like it's roughly like until here. It starts failing. I think here is failing because the light the light on the right, it doesn't show my hand very well. But let me try to do it without the extended disparity, so you can have an idea. And James said it's false. So forth.
So Jose,
Yes.
sorry for interrupt you. We have some question from YouTube.
Yes. Here.
So could you?
Just let me finish my point, and I will go to the question. So here now, it will start failing here. Can you notice the difference between the two cases? I hope that you can do it. So yeah. So Rain, yeah, please. Can you tell me the question?
Yeah. So it's from Hanging Joe. So he asks, have you ever tried OpenCV 2 in C?
For this tutorial, OpenCV 2 in C, I have tried it before, but I have not used the depth AI in C. But I think the depth AI is also available in C, right? Rick and Jacob, I think we have seen several code that is written in C, right?
Yeah, they're available on Python and C.
Mm-hmm. Thank you, Hanging, for your question. So what other stuff can you actually do to modify your stereo object? You could do, let me keep it as true because I think it's a little bit nicer. Set left right check. Let me set this to true. So yeah, so in this case, I think it would be very hard to, I don't know how to demonstrate the effect of this thing, but left or right check is a property that allows you to deal better with occlusions. Maybe Rick or Jacob could give a little explanation of what happens when you set this parameter to true.
Okay, so in this mode, it's actually, as we can see, the left and right image is slightly different. So if let's check the disparity calculated from left to right, then you will also check the disparity calculated from right to left, and you will compare the result it got. And if the result is like too much, and you will say, okay, this disparity is invalid.
Yeah. So yeah, so just to kind of say again what Rick said, that typically you would start with the image on the left, and then you would try to find you pick a point in the image from the left, right? And you try to find that point in the right image, and you calculate the disparity like that. So now this left right check, what it would do is that it will also get the right image, pick up the same point there, and try to find it on the left. And if the disparity is very large, like if you get, then you'll get two disparities, right? If the disparities are very large, it means that okay, there's something wrong. There must be like a false positive. So then it would just make it invalid, and it will make it 0. So, well, maybe we could see how many black pixels are, like how many noisy pixels are here. Is it very blackish? When I set to true, when I set it to false, well, it's kind of hard to see the difference. In this case, yeah. So this is how you would collect data, how you would extract the information and calculate the depth from the 3 cameras. If any of you in the audience have any questions or comments.
Yes, there's question here.
Okay.
So it's from Dipesh.
Okay.
The question is, can you please explain in PowerShell again about 0 and 190?
Sorry,
what exactly is it?
There's a little problem with your microphone. I couldn't hear you very clearly. Could you explain what?
So could you hear me again?
Yeah.
So the question is, can you please explain in PowerShell again about 0 and 190, what exactly it is?
Oh, yeah. So thank you, Dipesh, for your question. So this is when you set the extended disparity as true. So the default disparity in this camera is default maximum search for disparity is 0 to 190 to 96, right? So that means that you would get the, so let me set this to false again. So this is just the default stuff, right? So if I set to false, it will go from 0 to 95. Okay. So what it would do is that you will get a point in the left image, and then you will try to find it on the right image, right? And that's how you find the disparity. The disparity is the difference in the 2 pixels, in the difference in space of the 2 pixels in the epipolar line, right? So so if the object is close, you can see that the difference is very large, as opposed to if the object is very far away. If the object is very far away, if you look at the 2 cameras, basically they could see that it's almost at the same position, right? But if the object is very closer, you can see that the position is actually changing quite a lot. Now, basically my left hand is, you can see that it's very clearly on the right side of the for example, in the left frame, my hand is on the right, and on the right frame, my hand is on the left. If I move my hand very far away, the hand is basically in the same position, right, for both of them. So you allow a disparity search of 96 pixels, right? So that means that, and that bounds your minimum length that you can calculate disparity from, because as you can see, as I get my hand closer, my hand looks fine. Like, you know, it still can give you like a constant, a very nice disparity across my hand. But as I get closer, right, I get inside the minimum depth, and it starts going crazy, very noisy. That's because, you know, it's like our eyes. So our eyes, they do some kind of triangulation effect, right, between the object and your 2 eyes to identify the depth. That's the same thing. Like if you, for example, put your finger very close to your eyes, you wouldn't be able to tell like where is that finger. It'll be very hard, right? So that's the same thing with the camera. So when you set the extended disparity, so here what it's telling you is that the minimum change in pixels is 0, the disparity is 0, and then the maximum is 95. And then when you set the extended disparity to true, you allow the maximum disparity search to be double, or almost double of this 95, right? So that means that I can get my hand half as close, like half as close to the camera as I was doing before. Like you see right now, my camera is quite close to the camera. My hand is quite close to the camera, and it's still not getting very noisy until now. You see the difference of the depth that I can get the information from. So now let me demonstrate again. This is with the extended disparity set as true. Look how big my hand is in the RGB frame. It's very, very close to the camera. And it's until right now that is getting the error. As opposed to, what if I set the default value, which is the extended disparity, as false? Now, I want you to notice again until when does it start failing here. Here is that it starts to fail. So that's basically the difference. Thank you again for your question. Yeah. So as I mentioned before, let me just jump quickly to my presentation before before we do something else. So, like I mentioned before, right, the workflow for these kind of codes is you typically import your packages, your depth.ai and other packages. You define your pipeline. You start the pipeline, so meaning that you're going to assign which device is going to use which pipeline. You're going to get the data from the queue, and you're going to start the post-processing. So now, does anybody else have any other questions? Anybody else from the audience? Maybe no? Okay, nice. So now, before we jump into the next part of the workshop, which will be, okay, how do I get multiple cameras together to collect data from using the same computer, and how to encode video and test the limits of the camera, we are going to take a very short break, and we will be back in 10 minutes. I would like to ask everybody in the audience to please think of a question that you would like to ask during the break, and try to add it. We will pick some of your questions when we come back, and we will see you soon. We'll see you very soon.
Okay, Jose. So we got one question from the chat.
All right.
The question is from Michael. Very nice presentation and demo. What real-life scenario we can use the depth and the disparity setting? Thank you.
Nice. Thank you, Michael, for your question. Here I would actually like to ask my assistant hackers if they could come up with some idea for this one. What do you think, Rick? Where could we use this disparity and depth in a real life scenario? Jacob?
I will say first.
Yeah, one
Okay.
of each.
So in the Brandon's presentation, in few days ago, it actually mentioned they start like thinking the car system, the ADAS. So that's the one thing you can use, like detect the person for car safety, something like that. Avoid the touch.
I think that's a very nice one. I think just to piggyback on your point as well, not only the pedestrians, not only the people on the street, but maybe like the car in front of you, right? Because let's say that, you know, if the car in front of you is, if you're going very fast, right, and you need to and you have, for example, like a camera on your mounted on your car that helps you like brake, you will need that camera to calculate that very quickly, right? Because that could be a life or death situation. But Michael, I think the reason for why we are doing this depth right now, this disparity, well, the disparity is inversely proportional to the depth, right? As Rick mentioned before, through the focal length and the baseline length. But the thing is that in the end, right, the nice thing about this OGD camera is that it allows you to do spatial AI. Spatial AI is a relatively new concept that, as we mentioned before, allows you to extrapolate these 2D neural networks into 3D, but we need to calculate the depth, right? The depth is the insertion information from changing from this object is in this position in a 2D space to now this object is in this 3D space, right? That's the interesting part. But thank you for your question again. Jacob, you would like to mention another application for when would a depth be useful in the real case scenario?
Okay, so for example, like just mentioned before, we may be using the 2D pose estimation, and we can add in the depths, and then we can know each joint will have the 3D coordination. So maybe for example, open pose will be 90 joint, then those 90 joint will have those 3D coordinate for those joints. Thank you.
Yeah. Like I said, you could extrapolate to object the output of object detection or pose estimation or semantic segmentation. All of these things can be changed into 3D, right? Generalized into 3D by adding depth. Yeah. Do we have any other question, Rain?
Yes, we actually have a guest joining our Google Meet. So, Deepish, very welcome you joining us. Could you please turn on your microphone and maybe ask your question? I'm pretty sure Jose will answer your question clearly.
Welcome,
Thank
Dipesh.
you, Rain.
Welcome.
Thank you, Jose. I hope you are doing well, and I really like the workshop. And there's a lot of things I've learned right now from this. There are two questions I have right now. So the first question is, does this camera provide night vision? And the second question is, uh, when we are recording the video, okay, so can we do zoom in and zoom out in the video when we are accessing to Python?
Uh, yes. Good question, Dipesh. I first the first question, if it has night vision. I don't
Yes.
think it has night vision. Not that we know of. Now the zoom in, that's a concept that you could do in the post processing, right? If you would like to, for example, like zoom in and zoom out. But I am currently not sure if you could do that, like establish that parameter directly in the pipeline, right? But I know that you could zoom in by just doing some operations like on the post processing, right? That's for sure. But yeah,
Okay.
thank you for your questions.
Thank you.
Nice. We have any other questions, Rain, from the chat? No.
No, for now, no.
All right. No problem. So now let's move into the other two, the last two codes that we have for today, which are, I would say, they are quite essential if you are using this camera to for example to do a project like a practical application, not just in a lab. So this is for you. Then I suppose you will be you find this very interesting. So now let me change back to my Zoom. Let me share my screen here. And let me change back to my Zoom camera. Okay. So let me create a script that, just wait for me a second. Let me save it as test2. So now the question is, I want to have two cameras, right? I don't know. I would like to have two of these cameras collect data at the same time, right? Using the same computer, so, or the same host, right? So the way that you do this is to use the execstack function in the context lib library. So this is like these are like context managers, and context manager allow you to allocate and release resources whenever you want, precisely whenever you want. In practice, execstack is just used for making the code much more cleaner, like, and much more scalable. And I guess you will understand when we show the code. So let me now connect my two cameras. Let me connect my two cameras to the computer, and let me open the code. So how can we know that I have two cameras connected to the computer? We do the same thing as we did for the installation, right? So let me import depth as die, and let me print die device get all available devices. So let me see what do I get when I run this code. Okay, so yeah, the cameras are connected, right? There's two objects here. Let me make this one a little bit bigger. Oh. Okay, there are two objects here. And now I need to import also TV2, and I think that's the only thing that I need. If I need something else, I will import it later. So now I need to create a pipeline, right? The first step is to import the packages. The second thing is to define a pipeline. Fortunately, this pipeline is quite easy to create. You define a pipeline, you define a function that's going to return you your pipeline, right? Your pipeline is the API pipeline. And as I mentioned before, if you guys are not doing this at home or where you work, you should do this. You should test your code. Run the code to see if you have any bugs as you're coding it. The pipeline is just calling out this function. Okay. But it is empty right now. So let me put some more stuff before I test it. So the first thing is just, since I just want to collect the RGB data, I was just gonna create a cam RGB object. It will be pipeline create color camera object. Let me set a resolution, a preview size of the same thing that we had before, 640 times 400. And let me link this to an Xlink out. This is a pipeline create Xlink out node. Let me set the stream name for this. Set stream name RGB. And then let me print create the color camera object. And okay, let me run this code right now to see if it's working. Okay, print the stuff, no problem. No problem. So now let me just simply link the camera and the Xlink out node together. So let me link from the RGB. What am I going to link? The preview. Link to what? To the Xlink out RGB to its input. Right? I think this is everything I need. And then I will write create a pipeline. Okay. And I'm going to run this code. Okay, no problem. Right now, there's no problem. So now, the trick here is to first start with an empty list, right? Oh. And in this list, we're going to append all the queues, right? That you're going to get. So now we're going to using the context lib managers, the context manager. So we go with context lib exit stack stack. What are we going to do? We have two cameras, right? So then we need to get the information from those. So for device info in, and what is this? Is going to be this thing on the top. in die device get all available devices. Each one of these, what are we going to do? Going to set device equals now stack, okay? Enter context, and then we're going to define, as we have done previously for the device, this is device, okay? But now the device requires a pipeline, and then I'm going to specify that which ID, so which of the cameras are going to get which pipeline. So in this case, both are getting the same pipeline for collecting RGB data. So it will do it for all the devices here, okay? And then I will just print connected to, and then I'm going to just get device info, get library. Okay, so this is going to just print to which device is connected, to which the ID of which device is it that is connected. So now I have my device, then I need to start my pipeline. Device start pipeline, as we have done before, and we need to define the queue. So the queue in this case is queue is device get output queue. Which queue? Well, the only one that we have here, RGB. And then max size, let me set that as to 4 as well, and let me set it to have a blocking behavior, to not have a blocking behavior. And then we are going to append this queue to the list that we have. So to the empty list that we have. Okay, so now I have a list of queues, right? And now I'm going to start doing stuff with those queues. So I'm gonna go while true, and then for I and QRGB in enumerate. What am I going to enumerate? The items in my QRGB list. What am I going to do? So then I have my queue. I'm gonna get one item from the queue. In RGB is QRGB tag get, right? As you remember, as we have seen from before, this is a depth-AI image frame, so we need to convert it into a NumPy matrix by doing this function called get CV frame, okay? And then I want to show it. But I need to be very careful here because I need to, if the window has the same name, it will override it. So I need to just create windows of different names. So stri. So that's why I enumerate them. And then I'm gonna load the RGB frame. And finally, I'm just going to write this statement for terminating the code. CV2, or if CV2 wait key 1 is equal to the ordinator, the key ordinator that is q, then I'm going to break my loop. Okay, so I guess this is fine. Let me try to run this code to see what do I get. Oh, context loop is not defined. Oh, yes, I need to import that package as well. Okay, let me import that package. And now, okay. So I hope that you can see here. This is my OGD1 staring directly at me, and this is another OGD, and they're both running simultaneously. Okay. If we didn't use the exit step, then we will need to automatically write with this device, apply this pipeline with the other device, do the other pipeline, and that's not scalable, right? So that's why exit step is actually help us to have a cleaner code and make it more scalable, because there might be the cases where you need 3, 4, 5, 10 devices, right? And you cannot write that in the same line of code. So it's just easier to do it this way. And this is the way that is recommended by DepTI, and this is the way that I'm showing you. So if you guys have any questions on this, please write in the chat. We'll be happy to answer them, to try to answer them. Yeah, this is actually quite simple. One thing that, so one thing that you will notice is that when you started and when you quit it, it will take longer. That's because of the context manager that is trying to manage all of the stacks. And then but that's the only thing. So does anybody have any question in the chat? No? Nice. So now that we have looked into this, I would like to know what kind of projects do you have with the OGD? You know, are you working for maybe pedestrian detection? Are you working maybe autonomous vehicles? Are you working for, well, we're working with Parkinson's disease patients? Please write in the chat. Let us know what kind of projects are you working on with the OGD, or why do you want to learn how to use the OGD? That will also be good for us. If there is no comment, question, or concern, then I guess we will move into the last part of this workshop. So the last part of the workshop, let me delete this. Okay, so here we have done it. So then we move into encoding the video data into a compressed format, and we will also test the limits of the camera here. So the objective is to create a system that can collect images in H.265 and we will encode the RGB image in H.265, and we will encode the monochromatic images in H.264. Similar as we have from before, we have this host device interaction diagram. So let me jump to the code, and then I guess my assistant Jacob will give you a very brief rundown of this diagram. Wait a second, Jacob. I'm going to move the stuff here. Let me just move it to. That should be video encoder. Oh, I think it's better if you just. Can you see the diagram? Are you able to see the diagram right now in the screen? Yeah. Okay. Maybe you just I can just show this. Yeah. Go ahead, Jacob.
Okay. So as shown in this figure, as a device side, we're using the control command and to open the middle camera, middle RGB cameras, and we also open the left-right mono cameras by control command. So as this way, we will have the three objects one times. Then after that will be sent to the video encoder, and this video encoder output will be the device to the host side, and by this called the slink-out function. Okay, so let's jump to the host side, and we can see in each box we have the 3 boxes here, and the 3 objects will be sent to here. We just created previously. Then so we're using these 3 boxes in the function will to transfer them to the normal video forms. Okay.
Thank you, Jacob. Rick, would you like to add something or make a comment?
Okay, so with this encoder, we actually transform, or say collect the data to the H265 and H264 file, which is compressed by format.
What other formats are available in the for us to save the data? Is there any kind of lossless compression format?
Yeah, they provide a lossless conversion format is called NPEG. And I want to say it's the difference between the 264 and 265. Actually, the 265 is kind of advanced version of 264. Yeah. So the major difference is even in the same video quality, the H265 will save around 50 to 15 to 50% the storage space, as I think is the best advantage of using a 265. Yeah.
Right.
The this feature is like when your image is very complex, like you have made color, you have made light. But if the image is very simple, that the advantage is not very clear.
All right.
Yeah.
Nice. Thank you, Rick. So here, yeah, so here there are actually several objects that we need to create. We need to create in total 1, 2, 3, 4, 5, 6, 7, 8, 9 objects. So it's going to be quite a long pipeline, but you would realize that the structure of the code is the same. First, I'm going to create a color camera, and now I need to just define several properties. So the first property is to, I need to define the resolution. I have set this color camera to be 1080p for right now. And then I set it to be 60 FPS. Okay, this is the FPS of the color, left, and right cameras. So, and then I will print here. Print created color camera. Now the next step I would say is to create my two mono cameras. So mono left is pipeline create mono camera. Mono right is pipeline create mono camera. Then I need to set which one is left, which one is right, which board socket. It will not know by itself. So mono left is set board socket die camera board socket. Which board socket? The left. And mono right set board socket die camera board socket, and then right. Okay, nice, perfect. So let me set the resolution again to 720p. So mono left set resolution. Okay, so if on my RGB camera it is color camera properties, then on my mono camera it must be mono camera properties. Sensor, no, not string name. Sensor resolution, the 720p. And mono right, it will be just that we have done for the left. It will be set resolution, the mono camera properties, sensor resolution, the not 400p, the 720p. Okay. Then I need to set the FPS. So mono left is set FPS, and that will be FPS 1. Second item in my FPS list. and then this will be set FPS to FPS 2, the third item. Print created mono camera objects. Okay, so let me follow my own advice and run this code to see. Oh, not that one. Oh, I'm running the old code. I'm sorry. Okay, no problem. It created the two things that we tell it to create. Oops. Okay, so now the third, the other things that we need to create are these video encoders and their respective X-link outs. So we go, let's call it VERGB, and then pipeline create video encoder. We need to create 3 of them. So VE left is pipeline create video encoder. VE right is going to be pipeline create video encoder, and I need to set some properties for these video encoders. How can they know what is the resolution that they need to save it, the frames per second, and which format? And then VE RGB set default profile preset. I believe the resolution for 1080p will be 190 times 180. And this, is that correct? Rick and Jacob, could you help me double check this?
Yeah, that's correct.
Okay, thank you. And then this will be die. That will be what? Default profile? A default profile preset? No? This will be
Is video encoder property.
set video encoder property and then profile, right?
Yeah, correct.
Okay, thank you. And then this will be H26. So this is the color one, so we want to set the color one in H265. And then VE. So then the video encoder for the left is set default profile preset, and for 720 it will be some. What will be this? Could you help me check, guys? 720 will be
1280 720.
Sorry,
1280.
Okay. Thank you. And then FPS 1, and then die video encoder properties profile, and then we want to save this in H264 main. Why did it do that? And then VE try is same thing as we have done before. We set default profile preset 1280 720 FPS, the third one, and then die video encoder properties profile, and we want to save this one as well in H264. Okay. And okay, so each one of these is also connected to an X-link out, right? Because we need to send this stuff to the computer. So then, well, X out VE RGB is pipeline create X-link create X link out, and then X out VE left is pipeline create X link out, and then X out VE right is price pipeline create X link out, and we need to set a stream names for these ones, right? So X out VE RGB set stream name, and I'm just gonna name it RGB, and X out VE left set stream name gonna be left, and X out VE right is going to be set stream name, and let's name it right. Okay, print created video encoder object. Okay, so let me run this code, see if I'm gonna get any error. No, everything is working fine, thankfully. So now I have all of my objects. So now the thing is to link everything together. So let's start by looking at the diagram, and then what is linked with what? Well, first thing that we need to link is the color camera and the mono cameras to each of the respective video encoder objects. So let me start by doing that. So cam RGB video link to the VE RGB to its input. Then I'm going to link the mono left out. Right? We're gonna link it to the video encoder of the left to its input, and mono right is going to be out link to the video encoder of the right to the input, right? Now we need to link the output, which is the output of the video encoder is a bit stream. Okay, we're going to link the bit stream output of the video encoders to each of the respective X-link out, and then finally we're just going to dump the cues values into some videos. Okay. Okay, so let's do that. So let's link. So what are we going to link? We're going to link the VE RGB bit stream link to what? Link to the X out VE RGB input. Let me check if this will run. Okay, no problem. And let me do the same thing for all the other cameras. So VE left, we want to link its bit stream, link it to the X out object that we created for it. And then lastly, VE right, bit stream, link it to the X out VE right input, and then we want to print that we have created a pipeline. And we run this code again. Okay, nice. Everything apparently worked fine. So now we have imported the packages, right? We have defined the pipeline. Then the next step is to start the pipeline. So now,
Jose,
Hmm?
before I interrupt you, we got one question from Dipesh.
So the question is, does video quality get affected after compressing the video?
Yes. If the compression is, most of the compressions have some kind of loss, right? There are some compressions that are lossless. That's why we were trying to explain that difference in the in the beginning. But it kind of it can, for most applications, I would say that the loss is negligible. However, if you are dealing with, for example, micro motions, like in our case, right, we are dealing with quantifying the motor function of Parkinson's disease patients, and that motion is actually quite small, right? And for us, that we need to have lossless compression. So it depends on you. That's why, I would like to know what kind of applications are you gonna use this OGD for? But yeah, it affects it, of course. But in most cases, it is negligible. Yeah, but thank you for your question, Dipesh. Anything you guys wanna add, my assistant hackers? No? All right. So let me continue with the code. So then I have imported my packages. I have defined my pipeline. And now the next thing will be to start my pipeline, right? Die device, gonna start the pipeline, and device start pipeline. Okay, and then let me just print that I started my pipeline. Okay, and let me run this code. I will hear my camera make a sound, pum pum, and then if the pipeline started. Okay, and then the next thing would be to do a while loop. Oh, no. So now we need to open our files. So no, the next thing will be to get the queues. Yeah, so queue RGB. In this case, this queue is going to be device get output queue. Which queue? We want to get the queue from the RGB. Max size. This max size should be the same size of your FPS. Let's make it FPS 0, and let's make it have a blocking of true this time. And let me do the same thing for the other stuff. Let me do max size FPS 1 or with blocking true, and my QRI will be device get output queue name. Which queue I'm gonna get? The right, the max size of FPS 2 and blocking is true. Now I need to open. So what we're doing now is we're gonna open 3 files, right? And with those file opens, we're just gonna dump the stuff that is in the queue. Okay, so if my queue has something in there, as you can see here, then we're going to just get that information and boom, and dump it in that file. So let me start by defining a path called what? Data. So this will mean that I will have a folder that is called data, and in my folder I'm gonna path RGB will be path plus RGB dot h265, and I'm going to have a path left. It's going to be path plus left h264, because it's 7h264, and path right is going to be path plus right h264. Okay, so this means that what I want to do is to create a directory or a folder called data, and then inside that folder I'm going to save these files with names RGB for the RGB one, left h264 for the left one, and then right for the right one, right? But right now I don't have the directory, so let me create a directory. So make dir. So let me show you. So if I go ls, it will show me all the stuff that is inside this folder. So you can see here, I basically just have my 3 codes that we're doing today. So I want to create a directory called data. So I make directory mkdir. And if I go ls again, now I have this directory here. So with that directory there, I am going to open with open what it should be my path RGB WB as let's call it file RGB. Then in addition to that, open path left WB as file mono left, and open path right WB as file. I know this line is getting quite long. File mono right. What am I going to do here? I'm gonna start my while loop, while true, and inside this while loop, I need to do I need to try to do something. So when you have this try except analyze syntax, you basically tell it that need to do everything because I will stop it, right? But what happens if I stop it? If I have, for example, dump on the RGB, dump on the left, dump on the right, but what if I stop it? Maybe it's in the middle of that code, right? And then the left, it would not save it in the same time step. So when you have this syntax, basically you tell it, you either do everything inside the try or you don't do anything, right? Yes, do you have any question?
Yes, we got one question here from the chat.
Mm-hmm.
So that one is followed by the previous one about the video quality. So if it affects, can we overcome this by some algorithm?
Good question. I would kind of need to know what is the effect of that loss. That question is interesting because, like I said, it depends on your application, right? So overcome how, like, that also involves like your goal, right? So it's kind of like a little bit tricky for me to answer this question. But the best way to do it, I suppose, if you really care about loss information, is to try a lossless compression format. That would be my recommendation. Yeah, regarding the algorithm, it depends on like what do you want to do, right? And how is the loss affected? Because I suppose that different compression systems have different effects on the data, right? So yeah, but thank you for your question. Who asked that question?
Fish.
Oh, thank you, Depeche. Nice. So let me continue doing this code. So while QRGB has, I'm going to get items from there. QRGB get, and then in RGB get data to file, and then which file? RGB. And then seemingly it's going to be the same thing. Well, actually, we can try this right now to see if it's going to work for at least the RGB one. And let me try to run this code. So it's starting. Okay, and it continues to run. Okay. And now, what if I go cd into my data and then ls? Okay, it did it. You see now, I have a file that is called RGB H265, and it has something in there. And because I didn't put anything on the left and the right, this has nothing. Okay. So now let me try to do the same thing for the left and the right. So while Q left has, does this Q have items in it? If it has, then you're gonna get those items, right? And you're going to dump them into my file. To the file mono left. And the same thing for the right. While there's stuff on my queue, you're going to get the stuff in my queue, right? And you're going to dump them into my file. On the file mono right. Okay. And let's try to run this code again. But let me go back because I don't have any scripts here. Okay, so now I'm just moving the camera around. And then I stop it. And then, so let me actually show you my file explorer. So, well, I can show you the terminal or my file explorer, but cd data ls. So now we have data from in the left, the right, and in the RGB. And now I can go into the OBD, into the data. And if I click on it to run it, I cannot run it with my video player. And you might be like, okay, Jose, why do you make me save it into this format and I cannot even read it? So the way that we can, and I will tell you just, we can the thing is that we can transform H.265 into a readable format for your player by running this by using this FFmpeg command. So you can write this in your code afterwards, or you can write it in this command line. But the command is FFmpeg frame rate 60, because we have saved everything at 60 frames per second. So then which file are we talking about? RGB H.265 C, and then RGB the element 7 into MP4. And let's see if we can do it. This one output file message. Maybe it's copy.
No, you should keep the C and also copy.
Oh, C and copy. Like this. Is it like this, Rick?
Yes, yes.
All right. Okay. Nice. So now, if I go into my file in my directory called data, I have this rgb.mp4, and I can play it using VLC Media Player. Okay, let me show you here. So you can see here that it is actually the video that I just recorded. Let me play it again for you. So this is where I picked up the OD, right? I'm moving it around. Okay. So now, what is the maximum resolution in frames per second that you can save the data on? So let's try. Can I save it? Let's say I want to save the data from my mono cameras into, instead of 60, let me save it into 100 and 100 frames per second, right? I want to increase the temporal resolution of my data. Is it possible? Do you think it's possible? No, it is not possible. If we take a look at the error that we are getting here, this one, it's telling us that we can only save, well, it says exists, that the video encoding configuration exists the total, in other words, all the encoder streams combined. In other words, the RGB, the left and the right, that bitrate exceeds the threshold of 4K at 30 frames per second. What does that mean? So what is the resolution for 4K, guys? My 4K is
8,
Hmm?
40,
40.
Yeah.
Times what? Or time?
2160.
And then at 30. Okay. So this is the maximum bitrate that I can get. Okay, let me copy that value here. Okay. And right now I have a total bitrate of that will be, well, let me check what I have here. Now with 100 frames per second. Let me make this one a little bit longer also, because since we don't need the other stuff, it will be here 1280 times 720 times, in this case I have 100, but I have 2, but okay, 100 times 2 plus 1920 times 1080 times 60, right? that give me this number. You can clearly see that this number is larger than this one, and that's what I'm getting the error. So so if you want to save the data from 3 cameras, using the 3 cameras available in the OBD, you need to consider this limitant. So of course, if you want to remain within the range, the easiest way is to modify the frames per second, right? If you want to high resolution in your image, high spatial resolution in your image, you need to decrease the frame per second. And if you want to increase the temporal resolution in your images, you need to decrease the spatial resolution. But the issue is that the spatial resolution is very coarse. Like you either have the 400p, 720p, at least for the mono cameras. For the color cameras, you have much more variety, like 400p, 720p, 1080p, the 4K, and 12 megapixels. But you need to consider you need to stay within this range. Otherwise, it will give you this error. Does anybody have any questions about this? No? Yeah, I think we already spent more than the 2 hours that was originally intended for this workshop. So lastly, just to finish, I would just like to thank everybody for coming to the workshop and attending. I would like to thank all of my team as well, all of the Nordling lab here. All of this work is not possible with each and every one of them here. I would like to invite all of you to the future workshops. In the future, I am sure we're going to be preparing much more interesting stuff for you today, because it was the beginning. It was kind of like an introductory course just to get our hands dirty a little bit with the OBD. But in the future, I promise you that we're going to have many more interesting applications. So stay tuned for that. I would also like to just share with you that you can go to our website here. Let me just make it a little bit shorter. You can register to our second online computer vision artificial intelligence workshop on August 16th. This one is going to be quite interesting, because here we're going to present our submission for the OpenCV AI OpenCV competition. So stay tuned for that. And yeah, so and here in the third one, I believe we're also gonna have the CEO of OpenCV to give a talk. So I'm also looking forward for that one. And then we also have many other experts, very interesting talks from a lot of experts in the field. So I recommend you to please check it out. Give us a like on your social media, and we will be expecting you. Thank you all for coming.